Today we are going to look at section 9.3 about arcs. Objectives today is to identify and define relationships between arcs with circles, central angles, and inscribed angles. We're also going to identify minor arcs, major arcs, semicircles, and then we're going to talk about their notation. Then we're going to look at some theorems relating the measures of arcs, central angles, and chords. So the first definition I want us to look at is going to be a central angle. A central angle. That's going to be an angle that is in the same plane as a circle and whose vertex, this is the very important part of it, the vertex is the center of the circle. So if we look here, we have an angle LKM, angle LKM. And since its vertex, which is point K, is also the center of circle K, then we can say that angle LKM is a central angle. The next word I want to look at is an inscribed angle. And that's going to be an angle that has a vertex on a circle and with sides containing chords of the circle. The next word we want to look at is the arc measure. The arc measure is going to be the same measure as the degree measure of the central angle that intercepts the arc. So here we have angle LNM. So you notice that angle LNM, the vertex is going to be point M, and that point is actually on the circle, making it an inscribed angle. So let's take a look about measuring arcs. So we have a central angle, angle ABC, and that measure is 60 degrees. And let's say we wanted to know what arc AC is. We wanted to know what arc AC is. Well, since angle ABC is 60 degrees, that means that the measure of arc AC is equal to 60 as well. Our next word we want to look at is called a minor arc, and that's going to be an arc measuring less than 180 degrees. Remember, an entire circle is 360. So a minor arc is an arc measuring less than 180, so less than half the circle. Minor arcs are denoted with two letters, such as AB, where A and B are the endpoints of the arc. In contrast to a minor arc, we have a major arc. A major arc is an arc measuring more than 180, so more than half the circle. Major arcs are denoted with three letters instead of just two. So you're still going to make it have a notation with the arc, but instead of using two endpoints, you're going to use three endpoints. And they're all going to be endpoints on the arc. So we have arc ABC, where A and C are the endpoints, and B is another point on the arc between A and C. The next definition I want us to look at is a semicircle, and a semicircle is an arc measuring exactly 180 degrees, so half the circle. So, with these definitions, we now have a postulate. We have the arc addition postulate. So we are going to be adding arcs together. So it says that if point B is a point on arc AC, then the measure of arc AB plus the measure of BC is equal to the measure of AC. We also have a theorem, and this is the major arc. And remember, major has to be more than 180. So the measure of a major arc, ACB, is equal to 360 degrees minus the measure of arc AB. So let's look at an example. Let's say that we know that the measure of arc AB is 50 degrees, and we want to find the measure of major arc ACB. So we can go ahead and use our formula. We don't know that the measure of the major arc ACB has to be equal to 360 minus the measure of arc AB. And since the measure of mark AB is 50 degrees, we can substitute that into our formula. So now that we have the measure of the major arc ACB is equal to 360 minus 50, which means that our answer for the measure of arc ACB is 310 degrees. The next definition I want us to look at is congruent arcs. So congruent arcs are arcs on congruent circles. So criteria 1, they had to be on congruent circles that have the same measure. They have the same measure, they are congruent arcs. So from that, we get a theorem, and that theorem says that chords on congruent circles are congruent if and only if they subtend congruent arcs. So they had to be part of congruent arcs. So if we're looking at circle B and we're looking at circle Y, and we say, well, circle B is congruent to circle Y. And we're also going to say that arc AC is congruent to arc XZ. Then we automatically know then that segment AC has to be congruent to segment XZ. So our next theorem says that in congruent circles, chords are congruent if and only if the corresponding central angles are congruent. So almost the opposite of what we just said. So here we go. We have circle B and circle Y, and they're congruent. And then we're going to say that angle ABC is congruent to angle XYZ, which means that the segment AC has to be congruent to the segment XZ. Here we have if circle B, circle Y are congruent and segment AC is congruent to segment XZ, then we automatically know that ABC angle has to be congruent to angle XYZ. So it works all ways around. Next theorem says that in congruent circles, minor arcs, remember minor arcs are less than 180, are congruent if and only if their corresponding central angles are congruent. So let's see, if we have circle B and circle Y and they are congruent, and we know that angle ABC is congruent to angle XYZ, then we can say that the arc AC is congruent to the arc XZ. We can also say that segment AC is congruent to segment XZ. Remember, we learned that in the previous theorem. We can also say that since circle B and circle Y are congruent, and arc AC and arc XZ are congruent, if those two things are true, we can say that angle ABC and angle XYZ, those are the central angles, are also congruent. All right. Our next theorem says that in congruent circles, two minor arcs are congruent if and only if their corresponding major arcs are congruent. So here, circle B and circle Y are congruent, and the major arc ABC is congruent to the major arc XYZ, then that means that the minor arc AC is congruent to the minor arc XZ. Next, we say if circle O and circle Y are congruent, and the minor arc AC is congruent to the minor arc XZ, then we can say that the major arc ABC is congruent to the major arc XYZ. All right, so let's look at a practice problem. I want you to go ahead, I'm going to explain the problem, and I want you to pause it and try for yourself. What we're trying to find is the measure of arc AB. So go ahead and pause for a moment, see if you can figure it out yourself, and then unpause and I'll go ahead and explain the answer. All right, so I notice that I have AD as a diameter, which means that this is a semicircle right here. And I know that a semicircle measures 180 degrees, which means that this central angle plus this central angle plus this central angle has to equal 180 degrees. So 45 plus 60 plus the measure of arc AB has to be 180. So 60 plus 45 plus my question mark will be 180. So 60 plus 45, that's 105. 180 minus 105 is 75. So the measure of arc AB would be 75. Now we need to find the measure of AE. So go ahead and pause the video. I will give you a hint. It's very similar to the previous problem. So pause the video, see if you can't find the answer. All right, so since AD is a diameter, that means that the measure of arc ED and the measure of AE has to equal to 180. So AE plus 30 has to be 180, which means that the measure of arc AE would be 150. All right, next question. We need the measure of arc DC plus the measure of arc DE. So I'll go ahead and work this one out. So DC is 45 and DE is 30, which means that together they equal to 75. Okay, so go ahead and look at this question. It's multiple choice, so 1, 2, 3, and 4. Those are your multiple choice answers. So go ahead and pause the video and see if you can't come up with the correct answer. So the question says, given circle M and diameters DB and AC, and that the measure AD is 108, find the measure of AMB. So we're looking for AMB. So again, we know that DB is a diameter, and we know that AD is 108, and we know that AD and AB have to equal to 180. So, and the AMB is going to be the same as AB. The same as AB. So 180 minus 108 is going to be 72, which would have been option 3. Next question. I'm going to go ahead, I would like you to go ahead and pause the video and figure out if you can get the correct answer. All right, so it looks like we're trying to find the measure of BMC, central angle BMC, which is the same as the arc CB, And since central angle BMC is a vertical angle to angle DMA, and we know that DMA is the same as the arc DA, and that's 108. Vertical angles are the same measure, so our answer would be option 4, 108. Next question. Given circle M, find the measure of DAB. So here we have DAB. A, B. Well, that is a semicircle since DB is a diameter, which means that's option 2, 180. Now we want to find DC. We want to find DC. And since AC is a diameter, that means 108 plus DC has to be 180, which means our answer is option 3, 72. All right, I hope that you took a lot of detailed notes. I'm going to be checking. I'm going to be checking that you attempted the practice problems when I said to pause and try them, and that you just didn't write down the answers. So if you just wrote down the answers, go back, do the work, show me the work so that I can see that you attempted them. I will see you next day in class where I can look over your notes. Have a wonderful day, and thank you for watching.